Hey there, so we're going to keep talking about exponential functions, and we're going to be talking about one of the familiar and very specific exponential functions, which is compound interest. So get yourself ready for notes. And when you're done, if you've completed the homework from yesterday, I want to really encourage everyone to fill out the nomination forms, get into that habit so that I can help you on any homework problems you're stuck on. So let's start these notes by reviewing the compound interest formula that a lot of you were introduced to in middle school, actually in my class. I'm not going to say all of you, but if we have here, we have the total, so the final amount of the investment or loan. And here is principal, and that is the original amount. So if it's a $4,000 loan and you end up owing $5,000, $4,000 is the principal, $5,000 is the total. R stands for rate, which is the percent. And you're going to want to make sure that you write that as a decimal. Now here, N, you see it shows up twice. N is the number of times it's compounded each year. And so for that, what that means is that if something is compounded monthly, that means that N would equal 12. If N is compounded quarterly, N would equal 4. If N was compounded annually, that would just be 1. And then finally, T is time, and it's always measured in years. So that's the important one. So sometimes it might say 9 months. That doesn't mean that T equals 9, that means that T would be equal to 9 out of 12. All right. So let's solve a couple problems with this. You're definitely going to want your calculator for these problems. So number 1, you borrow $2,400 at 6.8% interest compounded monthly. How much would you owe after 10 years? So what I find helpful with these, if I'm stuck, is I'm going to look at my formula and I'm going to fill in everything that I know from the problem. So, because there's 5 variables, there's a lot going on. So my total is the unknown. That's what I'm going to solve for. My principal is the original, so that's $2,400. My rate is 6.8%. That's not how we type that into a calculator. We type it in as 0.068. It's compounded monthly, so N is 12, and it's for 10 years. So once I have that plugged in, I want to type that into my calculator. Now when we write it out, we might write it out as T is equal to 2,400, parentheses 1 plus 0.068 over 12 times to the power of 12 times 10. Now your calculator, some of you will let it enter in like this, some of you won't. So what I would recommend that you are always careful of with this type of problem is where you put your parentheses. So the first ones are going to be just fine on your calculator, and you can just type them in as they go. Now the thing here is that if you do this, you're going to get the wrong answer. You have to put parentheses around both of those since they're both in the exponent. Let your calculator do the work. I would never make you do that by hand. And you end up with $47,282.22. So again, make sure you're putting parentheses around those exponents. All right, so now the question would be would you rather invest money in an account that's compounded annually or quarterly? Explain. Now, so the main difference here is annual, so N is equal to 1, or quarterly is N is equal to 4. So the main thing here is that the total increases faster when N is larger. So in this case, since we are also investing money, so we want the larger N, which is the quarterly compounded account, because we want to have more money. Now, if it was a loan, we would want the annually compounding account because that would have less interest. So depends on whether you're owing or investing, and that's an important thing to think about. Now, one thing that will be new this year is this idea of continuously compounding interest. So how much would you invest if you wanted to have $20,000, which is called the present value, after 35 years if the account has 8% interest continuously compounding? And that means instead of someone going in at the bank and saying, oh, it's been a month, I'm going to calculate the interest and put it into the formula, this is compounding always. Every second of the day it's compounding. So in terms of the question in number 2, if I'm investing, I want a continuously compounding account. If I can find one, they're pretty rare. But if I'm investing, that's what I want. Versus if I have a loan, I do not want that. Now the formula for continuously compounding is T equals P times E to the RT. Now E is a button on your calculator. This is a constant. It's approximately equal to 2.9, just like how pi is approximately equal to 3.1. It's a button on your calculator. For most of you, if you look at your TI calculators, it's going to be the second function above the division sign. You can also see it above the ln sign. And this is one where it's already got an exponent on it. So if you want to use that, you can. So make sure you find that button. You're going to be using it a lot this chapter. How much should you invest if you want to have $20,000 after 35 years if the interest is 8% compounding? So again, T, P, and E isn't a constant, so we're not having that, but we have R and T. So the only thing that's different is N, because N is infinite, which is not a number we can really plug in, so we use E. Our total is what we know. We want to have $20,000. Our principal is our unknown. Our rate is 8%, so 0.08, and our time is 35. So I'm going to plug that into my formula. 20,000 is equal to P times E to the 0.08 times 35. Now, in this case, again, E is a constant, so we can type this into our calculator using one of these two buttons. And so in this case, you might type it in as E to the parentheses to start off with, 0.08 times 35, close parentheses, and you should end up with 20,000 is equal to P times 16.4 something something something. Leave this in your calculator. Don't round it, because what you're going to do next is you're going to divide both sides by that number to get P by itself. And so what you're actually going to type into your calculator is 20,000 divided by, and you're going to type in just the answer. So whatever you just used. For most of you, this is going to be above the negative button. So if you look at the button that's got the negative symbol, ANS is the second function, so click second, and that'll plug in your answer to the equation. And your final answer that you get should be $1,216.20, because 8% is a really high interest rate. So you don't have to invest very much to end up with 20 grand 35 years later. Let me know if you have a question on anything to do with compound interest, especially the continuously compounding interest, and I will be available on Zoom, by email, or in the comments.